Mr. Thomas.
Well, howdy! Here we are with Chapter 8, Lesson number 6, the discriminant. This is something that we have come across already, but in higher we're going to take it a stage further. We're going to have some harder examples and some harder questions. Yeah! So, the discriminant, what's it all about? Well, to find the roots or solutions of a quadratic, ax squared plus bx plus c equals 0, you can do that different ways. One of the ways is to use the quadratic formula. Oh yeah. So, what is a discriminant? Well, this part here under the square root, b squared minus 4ac, is known as the discriminant. And why is it called the discriminant? Silence. Well, it's called the discriminant because it discriminates between the nature of the roots. What's all that about? Well, if you have your quadratic and you work out b squared minus 4ac and you end up getting a number less than 0, in other words a negative, then it means there are no real roots. Since if you go back to the quadratic formula, you'd have the square root of a negative, and you can't get the square root of a negative. What does that mean for your quadratic? Well, if you graphed it, it just means that there are no solutions. It means that the graph does not cross the x-axis or touch the x-axis in any way whatsoever. If you work out the discriminant, b squared minus 4ac, and you get it equal to 0, well, that means the roots are real and equal. And that means if you graph it, that your graph will touch the x-axis in one place. And if you work out b squared minus 4ac and you get something bigger than 0, then it means there are two real and distinct roots. And if you graph that, it means the graph will touch it in two different places. It will touch the x-axis in two different places, as you can see there. Again, that's just some previous knowledge. Let's start off with some easy examples then, and then go on to some harder ones. I've done quite a few for this, because it is an important part of the higher course. So example 1, find the nature of the roots of x squared. Take 3x plus 4 equals 0. When you were doing this in National 5 last year, you wrote down the values of a, b and c, because we need b squared minus 4ac. So a is the coefficient of x squared, in this case it's 1, b is the coefficient of x, in this case negative 3, and c is the number, the constant, that's on its own, here it's 4. Sub them in to b squared minus 4ac, and you'd have negative 3 squared, take away 4 times 1 times 4, which will give us negative 7. And you can say then that since b squared minus 4ac is less than 0, it means there are no real roots. Let's try another one. Example 2, find the nature of the roots of 3m squared plus m take 5 equals 0. Once again, you need these values for a, b and c. So a, the coefficient of m squared is 3, coefficient of m is 1, and the number that's on its own is negative 5. Sub them in to b squared minus 4ac, and we get 1 squared minus 4 times 3 times negative 5, which works out to be 61, and since it's equal to 61, you know b squared minus 4ac, the discriminant, is bigger than 0, so you can say there are two real and distinct roots. Example 3. Find the nature of the roots of x bracket x minus 3 equals negative 6. What do you do with this one? Perfectly right. Multiply out the brackets. You need it in the form ax squared plus bx plus c equals 0. So you need 0 on one side and you need your quadratic just in its standard form. So multiply out the brackets here. We've got x squared minus 3x equals negative 6. Add 6 to both sides and that is what you would get. From there you're back to what we were doing with the previous examples. Write down the values of a, b and c. A is 1, b is negative 3, c is 6. And then from there, if we want the nature of the roots, use the discriminant. b squared minus 4ac will give us negative 3 squared. Take away 4 times 1 times 6, which gives us negative 15. Once again, finish that off with a sentence. So since b squared minus 4ac is less than 0, there are no real roots. Oh yeah. Example 4. Find the nature of the roots of t plus 1 all squared plus 2t squared equals 8t. Again, this doesn't look the best. It's kind of ugly right now. So what you've got to do is get it into that form of ax squared plus bx plus c equals 0. And to do that, you multiply out the brackets. So t plus 1 squared means t plus 1 times t plus 1. Multiply all that out and you get t squared plus 2t plus 1. You've still got plus 2t, still have equals 8t. From there, move everything to the left-hand side. Simplify, gather your like terms, and we'd end up with 3t squared. Take 8t off both sides, we'd have negative 6t, and we've still got plus 1, that stays as it is, and that all equals 0. From there, write down the values of a, b, and c. So a is going to be 3, b is negative 6, and c is 1. And from there, to find the nature of the roots, we know we use the discriminant, b squared minus 4ac. So from there, negative 6 squared, take away 4 times 1 times 3, and we end up with 24. So you can say that since b squared minus 4ac is 24, so obviously it's bigger than 0, and that means there are two real and distinct roots. Let's move on to one that's a bit harder. Example 5, for what value of p does the equation x squared minus 3x plus p equals 0 have real roots? So for this one, again, let's start off writing the values of a, b, and c. We know a, the coefficient of x squared, is just 1. We know the coefficient of x is negative 3. And we know that the number on its own is a letter. But write it down anyway. Okay, so just write down it's p. So c is going to be p. And what we're asked to do is we're asked to find this value of p for which that equation has real roots. So if there are real roots, you know that the discriminant must be bigger than or equal to 0. So you can say that for real roots, b squared minus 4ac is bigger than or equal to 0, and then sub in what you know. You know the values of a, b, and c, so sub them in. You've got negative 3 all squared, take away 4 times 1 times p. The only unknown here is p, so you can work that out, which is what you're expected to do. So negative 3 squared gives you 9. That would be take away 4p, that's bigger than or equal to 0. I'd probably add 4p here to both sides just to make the value of p positive. So from there you've got 9 is bigger than or equal to 4p. I'd write that back to front, so if you read it from right to left, 4p is less than 9, so it's writing it that way. And then divide both sides by 4, p would be less than 9 over 4. And that is your answer, that's your value of p. Example 6. Find the value of k such that the equation kx squared plus kx plus 6 equals 0, where k does not equal 0 and that has real roots. So for this one, again, just start off writing down what you know. Write down the values of a, b, and c. A couple of you saying that you don't know what they would be because there's no numbers. Even if there's no numbers, write it down if it's a letter. That's absolutely fine. So here the coefficient of x squared is not a number, but it is k, so you can still write that down. So a would just be k. The coefficient of x, again, is k, so the value of b would be k. And the number in its own is 6, so you can write that down. Again, we're told that this equation, this quadratic, has equal roots. And if there's equal roots, you know the discriminant would be equal to 0. So b squared minus 4ac equals 0. From there, sub in the values of a, b, and c, and you get k squared minus 4 times k times 6. Multiply that out, that's just k squared, and that would give us minus 24k, and that all equals 0. To solve that, factorise. So take out the highest common factor, which would be k. So you've got k bracket k minus 24 equals 0, meaning then that k equals 0, or k minus 24 equals 0, meaning k would equal 24. So here we've got two values of k. Sandy, what are you shouting out? Brilliant. Sandy's reading the question. It says here that k does not equal 0, so you can ignore that answer, and the only answer we have is k equals 24. Just make sure whenever you get to the end, you go back and read the question. Well done, Sandy. Example 7. Prove that the roots of the equation 2x squared plus px minus 3 equals 0 are real for all values of p. So your solution. Well, here we're not having to work out the value of the discriminant. We're also not working out the value of p. we're told to prove that the roots are real for all values of p. So how do we start this off? Well, let's write down the values once again of a, b, and c. So we know a is going to be 2, we know b is going to be p, and we know c is going to be -3. Again, we're not having to work out the value of the discriminant, we're not working out the value of p. So let's investigate the discriminant because it's still talking about the roots and we're wanting to prove they are real. And we know that is using the discriminant. So b squared minus 4ac will give us, if we sub in the values of a, b, and c, p squared minus 4 times 2 times -3, which becomes p squared plus 24. Now if you think about that, if you've got p squared, the smallest value you could have when you square something is 0. Meaning then you'd have 0 plus 24. So no matter what value you put in for p, you're always going to get at least 24. So you know then, as it says here, p squared is bigger than or equal to 0 for all real values of p. So p squared plus 24 will always be a positive for all real values of p, meaning the roots will always be real. And the roots will always be real because no matter what value you put in for p, the discriminant b squared minus 4ac will always be bigger than 0, or always be bigger than or equal to 24. Let's try another one. Example 8. Show that the roots of the equation k minus 2 in brackets x squared minus 3k minus 2 in brackets x plus 2k equals 0 are real for all values of k. Once again, write down the values of a, b, and c for this one. So a, the coefficient of x squared, we've got k minus 2. The coefficient of x, we've got negative 3k minus 2. And the value that's on its own without any x term or x squared term is 2k. Again, show the roots are real for all values of k. Well, let's investigate the discriminant because that is what you would use to determine the nature of the roots. So b squared minus 4ac, subbing in there will give us negative 3k minus 2 all squared, minus 4 times k minus 2 times 2k. If you work that out, well, negative 3k minus 2 all squared, well, it means you're squaring, you're multiplying a negative by a negative, so the negatives will cancel out, and we'd have 3k minus 2 all squared. So 3k minus 2 times 3k minus 2. Work that out, and you'd have 9k squared. Take 12k plus 4. Multiply that out, you'd have negative 4 times, just multiply these two brackets, you'd have 2k squared minus 4k. From there, multiply those brackets, you've got 9k squared, take 12k plus 4, minus 8k squared plus 16k. Simplify that, 9k squared take 8k squared will give us k squared. We'd also have a plus 4k, and we'd also have plus 4. From there, again, show that the roots of the equation are real. How do you show they're real? We've got down to k squared plus 4k plus 4. What else could you do with that? Factorize! Yes, we can factorize that. If you factorize that, you'd end up with k plus 2 all squared. So that is the same as k plus 2 times k plus 2. And you know the smallest value of something when you square it is going to be 0. So you know then that k plus 2 all squared must be bigger than or equal to 0 for all real values of k. It will never be anything less than 0. Meaning then that the discriminant will always be bigger than or equal to 0. So the roots will always be real. Example 9. Find m if x squared plus mx minus 5 all squared equals 9 has equal roots. So for this one, we've got x squared plus mx minus 5 all squared equals 9. From there, multiply out the brackets. So we've got x squared plus mx minus 5 equals 9. From there, x squared plus, if you do mx times mx, well, mx means m times x. So really you've got m times x times m times x. So you've got m squared and you've got x squared. You'd have minus 5mx is minus 10mx, and you've also got plus 25, and that would equal 9. Remember, when you write this, what you're needing is a coefficient of x squared, coefficient of x and a number on its own. So here take out x squared as a common factor. So we've got 1 plus m squared times x squared. That's just taking the x squared out of here and here. So it's 1x squared plus m, 1x squared plus m squared x squared. So you would have that. Take away 10mx, and if you subtract 9 from both sides, you'd have plus 16 equals 0. From there, you know there's equal roots. If there are equal roots, then you can say that the discriminant b squared minus 4ac must equal 0. So minus 10m squared minus 4 times 1 plus m squared times 16 must equal 0. Multiply that out. Again, if you multiply negative 10m by negative 10m, two negatives will make a positive. 10 times 10 is 100, m times m is m squared. That would be minus, if you multiply all of them out, it gives you minus 64 m squared. 100m squared minus 64m squared gives us 36m squared. Minus 64 equals 0. From there, take out the highest common factor, which would be 4. So you've got 4 bracket 9m squared minus 16, which you can write as 4 bracket 3m plus 4, 3m minus 4, because you've got a difference of 2 squares. Find out the value of m. Well, you've got 3m plus 4 would equal 0, and 3m minus 4 would equal 0, meaning then that m would equal negative 4 over 3, and m would equal 4 over 3 if you set each of these brackets equal to 0 and solved for m. Example 10. If x squared minus 3x plus 3 over x minus 2 equals t, show that x squared minus t plus 3x plus 2t plus 3 equals 0. And hence, write down the values of t for which the above equation has equal roots. So to start with, we're wanting to rearrange this in order to get what we've got up here. So to do that, let's multiply both sides by x minus 2. I'll move the x minus 2 over to this side and multiply, and you'd end up with that. If you multiply out the brackets on the right hand side, you'd have tx minus 2t. And from there, really, because you're wanting it to equal 0, let's move everything to one side. So we'd subtract tx from both sides and add 2t to both sides. So from there, we've got x squared, take 3x plus 3 minus tx plus 2t equals 0. And from there, you're wanting to rearrange that. So you've got the x squared, you've got all the x terms together, and you've got all the terms without an x term together. From that, you can say that you've got an x squared. If you take out x as a common factor here, you can say that you would have minus, or take out minus x as a common factor here, you would have t, and you'd have a plus 3. That's taking out negative x as a common factor. And then you've got the plus 2t, and then plus 3, and that would equal 0. For part B, hence find the values of t for which the above equation has equal roots. When do you get equal roots? Or real roots, sorry? Real roots are when the discriminant is bigger than or equal to 0. So you can say then that b squared minus 4ac is bigger than or equal to 0. Write down the values of a, b and c. So a is going to be 1, b is going to be negative t plus 3, and c is going to be 2t plus 3. Work out b squared minus 4ac, so you've got negative t plus 3 all squared, minus 4 times 1 times 2t plus 3. If you multiply the brackets here, negative t plus 3 times negative t plus 3, two negatives make a positive, and you're just squaring t plus 3, which will give us t squared plus 6t plus 9. That will become minus 8t, and then minus 12. That would be bigger than or equal to 0. If you simplify that, you end up with t squared minus 2t minus 3 is bigger than or equal to 0. From here, what would you do? Perfect, yes, you would factorize, but you have to draw the graph. You're right. So from there, you would set your quadratic equal to 0. Just go off to the side and do that. Factorize it, so you get t plus 1, t minus 3 equals 0. And you think, right, well, t is negative 1 or 3, so that is what you would get for your roots. If you graph that then, it's going to cross at -1 and 3. The value of t squared, the coefficient's a positive, so you would get a smiley face. It looks something like that. Or sub another value, like 0, and in place here you get -3. So you know the graph would definitely be going down the way. And you know then that since you're asked to find the value of t, and you've got down to t squared minus 2t minus 3 is bigger than 0, you can find the value of t for bigger than 0 by looking at when the graph is above this x-axis, which is going to be here and here. So you can finish that off, and you can say that t is less than or equal to -1, or bigger than or equal to 3, because we're having to solve when it's bigger than or equal to 0, so you're looking above the x-axis, which is very similar to what we did in the last lesson. Try some of these questions. Again, the discriminant is something that we have done in the past, but it's taking it a bit further on to higher questions. Good luck!